Hey everybody, today we're going to talk about the distance formula. This is what you're going to need to be able to do. If I give you 2 points on a line segment, 2 endpoints, you're going to have to be able to find how long that line segment is. You're also, if I give you the length of the line segment and I give you one of the points and then I give you either the x or the y of the other point, you're going to need to be able to find the missing x or y. And it's very important that you memorize this formula, because it's just one you're going to have to know. In problems, they won't give it to you. So if we've got 2 points, in this case we've got 5, 3 and 18, 17, and if I was able to graph them and I wanted to find the length of those two, the line segment, then I've got a couple different options. One is I could go ahead and draw a right triangle. If I did draw a right triangle, then I could use the Pythagorean theorem. In order to use the Pythagorean theorem, I'd need to know how long each side was. Well, in this case, all I do is subtract the y's, or the x's, 18 minus 5 is equal to 13. So obviously that red line is going to be 13 units long. Count them if you want to check. And the y, from the y's, 17 to 3, if I subtract 17 minus 3, that gives me 14. And if you count them, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. This is 14 units long. And then I can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And so here, this is one leg. This is going to be 18 minus 5, or 13. And then this is going to be 17 minus 3, or 14, and then I've got to square them, and it's going to equal AB, or the length, the hypotenuse, squared. Well, then what I've got to do is square these and add them together, and then square root it to find out what AB is. And that would give me this length of square root of 365. Now, let's take a look and see how we can make a formula out of this. If I don't use numbers for points and all I do is use x's and y's, well, if I do exactly the same thing and set up my right triangle, in this case, to find the length here, I'm going to subtract x2 minus x1. And then if I want to find the length of this leg, what I'm going to do is subtract y2 minus y1. Well, if I set that up, it's going to look like this. y2 minus y1 squared, x2 minus x1 squared, and then it's going to equal the length squared, or that's the hypotenuse. Well, if I go ahead and square root both sides, you'll recognize this formula from Math 1 and probably Math 2. This is how we can find the length or the distance between 2 points. And all we've got to do is plug in the x's and y's and then use the formula. So you may have seen it look like this. They call it the distance formula. It's kind of weird because most often we're going to use it to find the length of a line segment. So let's think of our problem. We've got to find a distance between A, 4, 8, and B, 1, 12. So first thing is that we should write our formula down. And then what we're going to do is we're going to plug in the x's and the y's in the formula. And then we're just going to basically do what it says. So we keep in mind we've got to follow the order of operations. We're going to do 1 minus 4, and then we're going to square it. And we're going to do 12 minus 8, and then we're going to square it. And we're going to end up with 9 plus 16, which is going to be 25. And when we square root that, we find out the length is 5. All right. So try this problem on your own. Find F, G, and J, K, and then determine whether they're congruent or not. Pause the video and then try it, and then start back up again when you're ready. All right, hopefully you did that. So if we're going to put our coordinates here, we're going to use a distance formula. And basically it's going to look like this: 5 minus 1 squared, 5 minus 2 squared. We're going to take the square root of that, and we're going to end up with 5 for the one length. And then when I do the other one, I'm going to find out that it's the square root of 18 when I reduce it. Square root of 18 is square root of 9 times square root of 2. I can take the square root of 9. That's actually going to be 3. So it's 3 square root of 2. They do not match. They're not the same length, so we are not congruent. So this last part, What if I give you the length of a line segment and I need you to find part of it? For example, here I've got y equals 3, negative 8, and z is equals x4, and they tell me the length between y and z is 13, and they want me to find the value for x. So how do I do that? Well, this is obviously involving distance or length, and so we start by writing down the formula, and we plug in what we can plug in. In this case, I know the distance, so I plug that in. I know the part of the x's. I know one of them is an x and the other one is 4, and then I know the y's. One is 4 and the other one is negative 8. I plug in what I know into the formula, and you'll notice I only have one thing I don't know. So now all I'm going to do is simplify. In this case, 4 minus a negative 8 is 12, and then I obviously can square that. That's going to be 144. And then what I can do is I can square both sides, and that'll get rid of the square root side on the one side. So that would give me 13 squared is equal to x minus 3 squared plus 144. And then I can square x minus 3, and that's going to give me 169, which is 13 squared, is equal to x squared minus 6x plus 9 plus 144. And then I can simplify this, and then it's a quadratic, so I'm going to make it equal to 0. And I've got a quadratic of 0 is equal to x squared minus 6x minus 16. And solving quadratics, I'm going to try factoring it. Let's move it over here to the other side. And if I factor this, well, I'm going to break it apart. I'm going to find x minus 8 times x plus 2 is going to give me x squared minus 6x plus or minus 16. And then when I factor it, I pull them apart and make each factor equal to 0, and then I solve. And so then I find out that x is equal to 8 or x is equal to negative 2. All right, I hope that makes sense. Hope it's familiar to you. Take a look at this, and we'll get a kind of a graphic of this last problem. Okay, so we've got, I'm on Desmos here, and I'm going ahead and plotting this point y, and then z, which is some number 4. So the y coordinate is going to be 4, but the x could be anything along here. And so you can see we've got this wide array of points, but we're looking for points that are going to be 13 from this point y. If I take the one answer we got, negative 2, 4, you'll see that it is on this line y equals 4 that we had said it needed to be on. And then the other answer we had was 8, 4. There are two possible points that would be 13 away, and if you want to prove it, you can go ahead and use the distance formula using both these points and the point we knew already, and you'll notice they both equal 13. All right, I hope that helped. Thanks for watching.